Next question number 1. We want to draw y equal to mod x plus 1 and y equal to minus x in the same axis. So as usual, we can start with y equal x plus 1 for this graph, then y equal mod x plus 1, and then y equal 2 times mod x plus 1. So this is from here to here. This is a reflection of x-axis where fx less than 0, and we discussed earlier this one, and this is a vertical stretch with scalar factor 2. So we'll draw this one, y equal x plus 1, positive gradient, and plus 1, y equal x plus 1. Zero 1 coordinate, and the mod graph. So fx less than 0 in this area. So the graph is this part. So we have to erase this one and reflection of that part on x-axis. And then the vertical stretch of 2. So all the y values we have to multiply by 2. It's going to be something like this. So this is become 0, 2, because 1 times 2 is 2. This is 0, 2, and we know with this graph when y equals 0, x equal minus 1. So this is minus 1, 0, minus 1, 0. So this is the graph for y equal 2x plus 1. Then the other graph is y equal 2 minus x. We put to them y equal minus x plus 2, negative gradient, plus 2 is the y-intercept. So it's going to be going through 2, y-intercept 0, 2. So this is y equal to mod x plus 1, and this is y equal 2 minus x. So one intersection point is, it's very clear that 0, 2. So x value is 0 here. So we can write one answer for when we solve those two equations. One answer is x equals 0. By observation we can write. So other one is we want to find the coordinate of this one. Part B is we have to solve this one. So I write this is like 2 mod x plus 1 equal 2 minus x. A equal B, then B, I can write B equal A. That's what. Same thing. Then we have two options here. One is positive option and other one is a negative option. So I'll go with 2 x plus 1 and 2x minus x, and the other one is negative. So 2 x plus 1, so I want to put negative here, 2 equal 2 minus x. So this is minus 2 x plus 1 equal 2 minus x. Now we have to solve this one. 2x plus 2 equal 2 minus x. Then 3x equals 0, x equal 0. We got one answer, and the other one is minus 2x minus 2 equal to minus x, 3x equal minus 4x equal minus 4 over 3. Sorry, this is x, x equal minus 4. Minus 2x to other side positive, minus x, and x equal minus 4. Question number 2. Mod 2x minus 1, 11 equal half x plus k has two distinct solutions. So we have to find the possible values for k. We can do this. Let's draw this graph first. Y equal mod 2x minus 11. Another one is y equal half x plus k. This is 11 by 2, 0. You can draw now. And y equal half x first of all. And yeah, plus k. So let's say this is y equal half x plus k. When k is changing, this line is going up and down. So let's say this is k1, this is k2. Y equal half x plus k2. And for this equation and this line, there is no solution, there is no intersection point. Another one, y equal half x plus k3. K1, K2, K3 is the values of k. And this is another one. It's going to this point. Y equal half x plus k4. Only one solution, one unique solution for this graph and this graph. If it's going like this, they all parallel, half x. Radian is same. K5, yes. For this one, there are two distant solutions. Now we need to find the k for which case we have distant solution. So we know that for k1 there is no solution, k2, k3, and we know that for k4, or let's say that is k instead of, we have one solution. Then we can find this k value. So in this place, this is k1, 0 k1, 0 k2, 0 k3, y-intercept. So this is 0 k. So now I'm going to find, so I don't need this. I'm going to find this k value here. Okay, I will leave at k4. Since 11 to 0 on y equal half of x plus k4, it should satisfy the equation. So then I can substitute 1102 to here. So y is 0, half a times x is 11 over 2 plus k4. What is k4? Is minus 11 over 4. We found out this value is now this value 0 minus 11 over 4. Now you can see that any value greater than minus 11 over 4, any k value. So it has two distant solutions. So basically any value greater than k4 or which is minus 11 4. So we can write hence k equal minus 11 over 4, only one solution. K greater than minus 11 over 4, two distinct solution, and k less than minus 11 over 4 somewhere here, no solutions. Question number 3, we have to solve this one. So we'll take the positive answer first. Equal minus 1 over 4x plus 8, and the negative one minus 5x minus 2 equal minus 1 over 4x plus 8. So 5x minus 2, this is I will multiply by 4. 4 to 4 cancel out. 20x minus 8 equal minus x plus 32. So 21x equal 40. So x equal 40 over 21. And again this is minus 4 times 5x minus 2 equal minus x plus 8 times 4. So minus 20x plus 8 equal minus x plus 32. So then this one to here, this is going to be 19x, 32 minus 8, 26, 24. So x equal minus 24 over 19. Question number 4, we have to sketch those two graphs in the same sketch, same axis. So y equal, I can write like this as well, minus 5x plus 12. So first of all, we can draw minus 5x plus 12. Then we can put the mod value of this one. Graph this one has a negative gradient and positive y-intercept. And when this is y equals 0, x is going to be 12 over 5. Sorry, this gradient is negative, so it's not positive. So gradient is negative, so it should be like this. And this is 0, 12, and y equals 0, y equals 0, x equals 12 divided by 5. So this is the graph. And when it's come to mod, it's going to be a translation on x-axis of this part. Sorry, this is not a translation, this is a reflection of x-axis. X-axis where fx less than 0. And then this graph, negative gradient again, it's go to 0, 3, and when x equals 0, when y equals 0, x equals 3 over 2. So y-intercept is 3, and now 3 over 2, when y value is 0, x equals 3 over 2, and 12 over 5, which one is smaller? This is 1.5, and this is 5 times 2. So then the graph is going to be somewhere here. When you look at this video, this is a bit steep, but this is not. In that case, there is no intersection points. Hence, there are no solutions. Question part B, state with the reason whether there are any solution to the equation. There are no solution to the equation as there are no intersections. No solutions to the equation as there are no intersections. Or you can add intersections point. Question number 5. We want to show function this graph and curves are one-to-one function or not basically. Let's select one x value when x equal alpha. So this is alpha. This is also alpha intersection point, but this is beta 1 and this is beta 2. So same alpha, there are two y values. So same one alpha, we have two y values, beta 1 and beta 2. So this is one to many. If this is function is fx, so you can write alpha, and this is if alpha equal beta 1, if alpha equal beta 2. So this is one to many. So if one to many is not a function. Part B is a line. For any x value, let's say this is alpha 1, and this is beta 1. And if you take this is alpha 2, so this is beta 2. If you take alpha from domain and you have a one value, one y value for that beta 1. If you take alpha 2 from the domain, only one y value for beta 2. For any x value, you have only one y value. So this is 1 to 1. Hence, this is a function. Part C, you can see for one y value, y equal beta, so this is the range, right? Two x values. If you select alpha 1, still y value is beta. If you select alpha 2, still y value is beta. So this is many to 1. So many to 1 is a function. Hence, this is a function. Y equal beta line. So we can see that for same beta, there are three different alphas. So this is alpha 1 beta, this is alpha 2 beta, and this is alpha 3 beta. So same beta, uh, three different alpha. So this is domain and range, and this is many to 1. Hence, this is a function. Part A, let's consider this value alpha 1. We have beta 1, alpha 1, beta 1. So alpha 1, we have beta 1, alpha 2, beta 2, 1 to 1. And alpha 3, beta 3, 1 to 1. And alpha 4, no value. Alpha 4 is this dotted line. It's not 1 to 1 anymore. So you can't tell 1 to 1. Machine is broken. When we put alpha 1, we will get beta 1. When we put alpha 2, we will get beta 2. When we put alpha 3, we will get beta 3. When we put alpha 4, nothing. Nothing come out. So then this is not a right machine. So this is not a function as okay, when x equal alpha 4, if this function is fx, if alpha 4 does not exist. Only this value, this problem is there. If you select alpha 5 here, yes, alpha 5 has a beta 5. I'll assume this is beta 5. So likewise for all other values, there is a for all other value except alpha 4, there is a value in range. The only problem is L4, alpha 4. So if you want to make a function, this one, so we have to take this value out. Then you have to define domain. X is the element of real number, but x cannot be alpha 4. Now this is a function. That's how you make this set up as a function. We took out the problematic domain value, which is alpha 4. In other way, don't put alpha 4 to this machine. That's the guideline given. Part F. If we take any point alpha 1, we have alpha 1, beta 1. This is beta 1. And if we take other point alpha 2, beta 2, alpha 2, beta 2. Basically, alpha 1, beta 1, alpha 2, beta 2. Likewise, this is a function that is 1 to 1. Hence, this is a function. This is in general. Sometimes someone may say that, okay, if they consider domain from here to here, then there is no value for x equal alpha 3. There is no value. In that case, this is not a function because there is no y value. The graph is not exist there basically. But in general, in that case, someone can tell, okay, up to here, then alpha 5 is not defined. So here, if the graph is fx, so f alpha 3, no value, and f alpha 5, there is no value. And this is not a function. Anybody can argue with that as well, but in the exam they will clearly show that what is the domain they really properly mention. So for me, so basically I'll consider like this, and even in general, even we consider this is just axis. The graph is from here to here. So basically we should assume the domain from here to whatever the graph length. Hence in general this is a function, and it is a one-to-one function. If you want more precise, okay, just delete those areas. And this boundary is exactly the same. This starting point is exactly the same.